This video will cover the Geometry Common Core exam from June 2015, questions 32 through 33. Number 32 is the first 4-point question, which means that it requires a little bit of work, more than we've been doing, in order to solve for the answer. In the diagram below, EF intersects AB and CD at G and H, respectively. And GI is drawn such that GH is congruent to IH. This is a piece of information that so many students skip over, and unless you mark it on your diagram, you're not going to be successful in this problem. And we also have to mark up this information down below. Measure of angle EGB is 50 degrees, and the measure of angle DIG is 115 degrees. Explain why AB is parallel to CD. Now, in order to get parallel lines, we have to have congruent angles. And we have many options for that. The first option is alternate interior angles congruent. That's your average Z. The next option is alternate exterior angles congruent. We can also find corresponding angles congruent. Or we can talk about angles being supplementary, such as same side interior or exterior. Same side, interior, or exterior. Summing to 180 because, again, they're supplementary. So because we have to explain, we're going to explain as we work. That way we don't forget any steps. My goal is to figure out why AB is parallel to CD. So I have to find more angle measures. First, I'm going to find the measure of angle GIH. That's this one here. GIH. I notice that it's sitting next to 115 degrees on a straight line. If I have two angles on a straight line, I know that they sum to 180. So I'm going to take 180 minus 115. And that gives me 65. So that means that the measure of angle GIH is 65 degrees because two angles on a straight line sum to 180. My next step is to use the fact that I have two congruent sides. If I have two congruent sides, then I must have two congruent angles. So here, this side gave me the angle of 65, which means that this angle is also 65. So I'm going to state that as well. Measure of angle HGI is equal to 65 because an isosceles triangle, isosceles has two congruent sides, that's how I knew it was called isosceles. An isosceles triangle has two congruent base angles. Okay, so now we have 65, 65, but we're missing an angle in the triangle. This angle right here. So maybe if I can find that, then that can also help me figure out why my lines are parallel. I know that three angles in a triangle, 65, 65, and say X, are supposed to sum to 180. 65 and 65 sum to 130, plus X equals 180. Subtract 130, so now I find out that X is supposed to be equal to 50. That's interesting because there's another 50 on my paper. We'll think about that other 50 in a second. So I'm going to state that the measure of angle GHI equals 50 degrees because three angles in a triangle sum to 180. Now, thinking again back to the 50 and the 50 we see on the picture, we have a 50-degree angle here in yellow and another 50-degree angle here in yellow up top. If they're both 50, that means they're congruent. So it must be one of these three options, alternate interior, alternate exterior, or corresponding. Remember, alternate interior is a z, and we don't have that here. Alternate exterior is opposite sides of the transversal and outside of the parallel lines. But this angle here in yellow, GHI, is inside of the parallel lines. So I think that corresponding angles is our option here because corresponding means matches up. And if I were to take this whole angle up here and plop it down here, it would be in the same position as it were originally. So the measure of angle GHI equals measure of angle EGB. This is not really a necessary statement, but it tells us that we have congruent angles, which would then tell us that we have parallel lines. So therefore, I'm just going to scroll up a little. Therefore, AB is parallel to CD because corresponding angles are congruent. Question 33 says, given quadrilateral ABCD is a parallelogram with diagonals AC and BD intersecting at E. Our goal here is to prove that the triangles are congruent. Triangle AED, notice I'm shading it in, is supposed to be congruent to triangle CEB. Again, shading that in. In order to prove triangles congruent, we have 5 options. These options include side, 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 angle, side, angle, angle, side, angle, or HL. But HL can only be used for right triangles. And we have no right angles because we don't have any perpendicular lines. So I'm just going to cross off HL. Because I have a given and a prove, I need to make a T-chart proof, where the left side is for statements and the right side is for reasons. Your first statement and first reason always come from the given. Because this is so long, I'm just going to draw an arrow here for the given. But if it were a test or a quiz or an exam, you would need to write it out yourself. I'm going to use the fact that we have a parallelogram to prove these triangles congruent, because with a parallelogram we understand that there are many, many properties, not many, I shouldn't say many, there's 5 properties of a parallelogram that would help us possibly prove the triangles congruent. So because of that, there are many ways to prove. I'm going to show you one way, but I'll talk about other ways to prove the triangles congruent at the end of this proof. When I think about the properties of a parallelogram, I know that opposite sides are congruent. So I can make a statement that says AD is congruent to CB. And this is because opposite sides of a parallelogram are congruent. Number 3. I also know that the diagonals in a parallelogram bisect each other, or in other words, cut each other in half. So I can say that AE is congruent to CE. I can also say that DE is congruent to BE, because again, diagonals bisect each other. Diagonals of a parallelogram bisect each other. When I look at my picture, I notice that I have 1 set of sides, 2 sets of sides, 3 sets of sides, which means that I can prove the triangle's congruent right now by side, side, side. Triangle AED is congruent to triangle CEB. And again, this is because of side, side, side. But as I mentioned earlier, there's many ways to prove this. We could have talked about vertical angles being congruent. We could have talked about opposite sides being parallel, which would then give you alternate interior angles that are congruent on both sides. 1, 2, 3, 4. So then we could have proven by AAS, ASA, SAS, or like we did side, side, side. Now the second part to this question says to describe a single rigid motion. Remember that a rigid motion preserves distance. That maps the triangle AED onto triangle CEB. Our options for rigid motions are rotations, translation, or reflection. So here I'm just going to zoom out a little bit so we can see the triangle and try to answer the question at the same time. I need to map triangle AED onto CEB, meaning A needs to move on to C, D needs to move on to B, and E needs to stay where it is. So if I want to take A and bring it all the way over here to C, and D all the way over here to B, it looks as though I'm rotating, capital R. And because I want E to stay the same, I'm going to rotate around point E, 180 degrees. Now if you also saw that we could possibly reflect here, you're correct. Remember that on a graph, a rotation of 180 is the same as a reflection through the origin. And the origin in this particular case is E. So we can reflect over point E. Either one of these answers would be acceptable.